Hello, Dr. Satputty here. So we are continuing with ammonia production. So in this second slide, we are looking at actual process of ammonia production. Again, the resources are taken from references shown below. Look at the major steps. Now, as we have seen before, the basic requirement for ammonia production is hydrogen and nitrogen. Nitrogen is freely available from air. Now, in case of hydrogen, we saw the major method used is steam reforming of methane. So when you speak of reforming, there are now this particular process or hydrogen reacting with nitrogen to get ammonia involve a catalyst. Now we have to look at that there is no contaminants which can deactivate the catalyst. So can you please think of for a 10 second what would be a deactivating contaminants? Yes. So what would be there? Sulfur in the form of SO2, correct? Or as a reaction we saw, what comes out with hydrogen is carbon monoxide. So we required a hydro desulfurization which will remove a sulfur contaminants which can deactivate the catalyst and hence reduce yield of a process. Then we undergo reformation which has carbon monoxide. So we need to selectively refine, take out hydrogen out of it. C in gas purification which only take out selectively hydrogen which reacted with nitrogen to give you ammonia. Now there are different processes available. Now, as we discussed, the first process was a Haber-Bosch process. Haber is the one who developed a process in the laboratory, and Bosch is the one who scaled it to industrial capacity. So if you see a requirement of pressure and temperature, because there is a nitrogen available which is an inert gas, a very stable molecule. If you want to react it, you need to have a high pressure temperature condition. So you can see a temperature pressure condition for this is it operated around pressure of 250 bar, whereas temperature is around 400 to 500 degrees centigrade. So now there are different people who try to make it more economical. Now as you reduce a pressure requirement and temperature requirement, obviously a cost of ammonia will be less. So you can see that the pressure processes ICI, leading concept process, other Topsy process, Kellogg Brown process, Krupp Uday ammonia process, and Linde ammonia concept process. So what is happening in this, all the increasing development with ammonia production, there is an improvement in a catalyst. People are trying to use a different type of catalyst which can produce ammonia at lower temperature and lower pressure. The last process, Linde process, it proposed a use of 100 degrees centigrade and around 10 to 20 bar, on contrary to 250 bar and 400 degrees centigrade pressure in Haber-Bosch. So these are the different facilities required when you speak of ammonia production. Obviously you required a main production plant, then you required a storage application equipment like compressor pump to help it, then ammonia distribution system, then the transport system, shipping system, everything. Now this is overviewing raw material required and the process of ammonia production. Basically getting hydrogen, reacting with nitrogen and getting ammonia. You can see this process. It's a block diagram which shows this part shows a purification and getting hydrogen, and then you react into ammonia syn gas converter where you produce ammonia and then take out ammonia because the reactants are not completely converted into the ammonia. There are unreacted hydrogen, may not be hydrogen but unreacted nitrogen. You need to remove it from ammonia. This is the process of removing, and then finally you get ammonia storage. Now in the process of purifying the hydrogen, you went out CO2. You can see this is a desulfurization with removed sulfur, and then the reforming which have hydrogen, and then the reactor which gives you ammonia, and you get a series of chiller, a cooler which gives you ammonia in the end. Now one of the taxing technology here is a reforming technology. People have used gas heated reformer, basically tubular gas exchanger. So the energy efficiency of this process will decide ultimately the overall economy of ammonia production. Then they have developed autothermal reformer to make it more efficient in terms of energy use. You can see this example. It shows a feed gas. You have reforming here with secondary reformer implement, and you get a hydrogen. So your main thing is how do you, there is a constraint on the space and a better utilization of heat which make it more efficient. There is a pressure swing absorption, because when you take out ammonia you have to get into a pure form. It is a mixture of a lot of things, so it applies to reducing the hydrogen loss, getting more hydrogen, and also trying to get ammonia. For this process is mainly for hydrogen, and separation occurs based on properties of ammonia. So cryogenic separation is required because ammonia at 15 bar can condense at 40 degrees centigrade, whereas at 1 atmosphere it can condense at minus 33 degrees centigrade. So based on a different condition into a separation, you use cryogenic limit to take out ammonia from a mixture. Now you can talk catalyst. People are, as we discussed, the different processes based on improvement in catalyst. So the iron catalyst was developed initially. Now people are working with ruthenium catalyst, which is 40% more active than iron catalyst. Presently in India they are developing a process which can work at very low pressure and low temperature so that it becomes increasingly economical. So here start with ammonia separation using a temperature pressure combination. Thank you. So here we discuss the major two things: how do you get hydrogen, detail on how do you get hydrogen, then what are the basic, how does the catalyst develop for ammonia to make it more economical, and how do you separate ammonia. Thank you. Thank you.